Hi, my name is Tony Chen. I'm a product marketing director with Cadence. Today, I'm going to talk about addressing connectivity challenges in our data-centric world with PAM4 technologies and PCIe Gen 6. So let's first look at the driving force behind PCIe Express Gen 6 and beyond. It's really all about the data. Every day, a massive amount of new data is created, processed, and consumed. So what happens to all the data that are being created? Data are being processed by various AI engines in the edge and in the cloud. Data are also being analyzed in the big data centers around the world in the area of finance, health, and security. Data are also collected for advanced modeling and simulations. Examples including drug discovery and testing, automotive and aerospace, climate and weather simulations. As the data continues to grow exponentially, so have the demand for more I/O bandwidth. With the announcement of the official PCI Express Gen 6 specifications, PCIe 6 has managed to stay ahead of this bandwidth demand curve. These are the key updates in PCIe Gen 6. First and foremost, the data rate has been upgraded to 64 gigatransfer per second per lane. Also, PAM4 signaling has been adopted. Gen 6 incurs a low latency adder of less than 10 nanoseconds. A lightweight FEC is adopted to help with the reduced SNR. A new packet format called FLIT is defined. Finally, a new L0P power state is introduced. L0P allows the link to adjust the link width dynamically to stay powered. As with previous PCIe generations, PCIe Gen 6 is fully backward compatible. Let's look at the PAM4 signaling. In NRZ signaling, 1 bit is transmitted per symbol period. In PAM4 signaling, 2 bits can be transmitted per symbol period through multi-level representation. The real benefit of PAM4 is that data rate can be doubled without doubling the Nyquist frequency. Obviously, the goodness of PAM4 don't come for free. It does introduce additional complexity in its implementation. Electrically, on the transmitter side, the transmitter now needs to generate signal with nearly perfect linearity and symmetry. On the receiver side, the PAM4 eye opening is 1/3 of NRZ. Essentially, the SNR is reduced by 9 dB. Therefore, it places a lot of stress on the receiver to decipher the received signal accurately. The timing for adopting PAM4 was impeccable with advanced process technology nodes. DSP architectures can be implemented efficiently to tackle PAM4 signaling. DSP is typically implemented with a standard digital design flow, which is less sensitive to PVT, noise, and other environmental factors. Let's look at the PAM4 transmitter in more detail. On the left, we have a traditional high-speed NRZ driver with analog tap delay lines to implement FIR filter. For PAM4, we can actually use a combiner to combine two such drivers with a 2-to-1 ratio to generate PAM4 signal with a FIR filter. On the right, we have a DAC-based transmitter. In the DAC approach, the FIR filter is pre-computed and applied to the data in the digital domain to generate the DAC code. The DAC code can then be used to modulate the high-resolution DAC directly to generate the PAM4 signal with FIR filtering. Let's look at the PAM4 receiver next. Here we show a DSP-based architecture which can be implemented efficiently with advanced process node. In a DSP-based architecture, signals is first equalized and amplified by a VGA or CTOE. The signal then gets digitized by a high-resolution ADC. The digitized bits are then fed to a DSP processor to perform clock recovery and equalizations. Compared to a traditional analog architecture, DSP-based architecture typically can achieve better performance. Despite of having powerful DSP architectures, PAM4 signaling remains challenging due to the reduced SNR. Because of the reduced SNR, PAM4 is prone to getting burst errors. To address the burst errors and the added bit errors due to PAM4, PCIe Gen 6 uses a combination of lightweight FEC, CRC checks, and packet retry mechanisms. On the protocol side, a new packet format called FLIT is introduced. FLIT supports error correction. In addition, FLITs can achieve higher bandwidth efficiency and lower latency. Let's now look at the Cadence solution for PCIe Gen 6. Cadence is uniquely positioned to deliver the best-in-class PCIe Gen 6 solutions for having two key advantages. First, Cadence is a recognized leader in 100 gig PAM4 PHY IPs. Second, Cadence is also a leading provider of complete end-to-end PCIe solutions for nearly 2 decades. By bringing together our 100 gig PAM4 technologies as well as our extensive PCIe experience and know-how, Cadence is able to bring the best-in-class PCIe Gen 6 solutions to our customers. The codename for our PCIe Gen 6 PHY is Excelsior. Excelsior was designed with our most advanced DSP architecture, which can seamlessly handle NRZ and PAM4. Let's quickly look at the key feature of our Excelsior PHY. Excelsior is powered by an advanced DSP core with more than 20 taps of FFE and a single tap of DFE. It features a programmable multi-rate CTOE, which can be optimized for each PCIe data rate. It also features a background adaptive offset gain and phase correction mechanism. It supports S-RIS clock recovery in the receiver. It has a low jitter LCPL for the lowest jitter performance. It also has an on-die AC termination and T-coil to minimize the return loss. The PHY supports Pipe 6.0. The PHY will also support the L1 substate power management for the lowest standby power. Finally, the PHY supports the bifurcation mode natively. Here we show the PCIe Gen 6 controller architectural diagram. We have the PCIe protocol stack on the left and CXL stack on the right. Let's quickly go over the key feature of our controller IP products. The controllers support PCIe Gen 6 and CXL 2.0. In the future, it will also support CXL 3.0 when the standard becomes more mature. The controller supports root port, endpoint, and dual mode. The controller is designed to be highly scalable. It can support up to 16 lanes and 256 physical functions. The controller is designed for low latency, which is ideal for data-centric applications. The controller is also designed with high utilization in mind. It can achieve greater than 95% of link utilization. Finally, the controller provides very flexible bifurcation capabilities. To sum it up, PCIe Gen 6 is gaining significant market tractions. The increased bandwidth, the power efficiency, and the backward compatibility makes Gen 6 ideal for demanding applications such as hyperscale computing, advanced storage and IOs, as well as artificial intelligence. And Cadence has the complete end-to-end silicon-proven solutions for PCIe Gen 6. This concludes my talk for today. Thank you for your attention.